Hello and welcome to a Maths with Harry lesson. In this video, we're going to have a look at simultaneous equations on graphs. In the previous two videos, we had a look at linear simultaneous equations, and then we also had a look at quadratic simultaneous equations. And what we're going to do today is we're going to have a look at simultaneous equations on graphs. And if you've got a graph of two equations that you want to solve simultaneously, how can a graph help you? So, on the screen here, we've got some examples, and I've also got a sentence at the start. It says, the solution to a pair of simultaneous equations represents blank. If you want to have a think about what the solution on a graph represents, then pause and have a go. But if you've got two, and you can see here, for example, two linear simultaneous equations, we've got a straight line here, we've got another straight line, and they go on forever. I've just done some random lines there. Or we could have something that looks like this, one line here and one line here. The solution to the pair of simultaneous equations is the point of intersection. And you've probably seen this before. So, if you're asked to solve simultaneous equations graphically, what you want to do is maybe graph the two straight lines, or graph, if it's a quadratic, graph the quadratic, and you want to find the point of intersection. So, for example, if we have a look at these two, we can see there is the point of intersection, okay? The point of intersection is where just the two lines cross. So we've got one linear line here and another one, and they cross at the yellow point there, and then two other lines here, they cross at that yellow point there. And that might have a coordinate. So for example, that might be, I don't know, x is 5 and y is 12. And this point here might be x is -3 and y is, I don't know, -10, something like that. Two examples those were. That would be your solution to the simultaneous equations. X is -3 and y is -10, because that's the point of intersection. So those are two linear. Let's say we had a linear and a quadratic. The first one here is a positive quadratic. So it's where a is greater than 0, because that's our coefficient of x squared. If it's greater than 0, if it's positive, we get this nice positive or sort of U-shaped quadratic graph. And then blue here is the straight line. And we can see there's 2 points of intersection here, and that's because we used to, in the previous video, we used to getting 2 points of intersection, or 2 solutions to our simultaneous equations. And so there's an intersection and there's another intersection, and so the coordinates at that point and that point are the 2 solutions, or pair of solutions, to our simultaneous equation. If we have got, let's have a look what's behind here, a negative quadratic, you can see again, this is 1 point of intersection and this is another, and so those are the pair of simultaneous equation solutions. We can take this coordinate here at the orange dots and that coordinate there, okay? Now you might not always get an intersection, and we'll have a look at how we can sort of find that out before we actually start graphing later on in the video. But I believe, here we go, we have an example. So, pause and have a go if you want to. If not, we'll work through it together. It says, part A, on the same axes. So, you know, you just want one axis here, or one set of x and y axes, and draw both graphs on the same one. We want to draw the graphs of 2x plus 3y is equal to 8, and 3x minus y is equal to 23. And then once you've done that, part B says use your graph to solve the simultaneous equations. Now it's important here that you do use your graph. If you were to solve these simultaneous equations like we've done in our previous videos, you wouldn't get the marks, because it's asking you to use your graph, okay? So pause and have a go. I'll give you a little hint. Y equals mx plus c, if you remember, where m is your gradient and c is your y-intercept, is the general form of a straight line. And if you get each of these straight lines into this form, it will help you graph them. So pause and have a go, and then we'll work through the answer. Okay, if you paused, hopefully you have got an answer. Let's see whether you were correct. So I've already sketched these behind this box here. There we go. I can delete that. There we are. So I have got, and let's just get rid of that 7 there. I've got 2 straight lines. This is the first one, and we can see that, oh no, it's the second one actually, because I've minused 23 from both sides and added y to get it in this form here. And we can see then it's got a gradient of 3 and a y-intercept all the way down here somewhere of minus 23. So that is this one. We can highlight that like that. And then the red line, well, of course, it's going to be the other one. And we can see I've got, I have minus 2x from both sides and I've divided by 3. And then I've just distributed the 3 to both terms on the top. So we've got a gradient of minus 2/3 coming down like that because it's a negative. And a y-intercept of positive 8/3, which is about there. Now, just to note, my graph is not perfect because I don't have squared graphing paper here. You, in an exam, if you were to ask to do a question like this, you would get graphing paper, or a little part of the exam paper would be squared, but I don't have it here. So we're working roughly here, but in an exam you'd work perfectly and you draw your lines exact, okay? So that was part A, and that's all you needed to do. And then part B says use your graph to solve the equations. So all I need to do is find the point of intersection, which is that yellow point there, okay? So what I can do is I can go up to the x-axis and I can go across to the y-axis like that, and I can just read off the graph. We can see the x-coordinate of that point there is 7, and I can see that the y coordinate of that point working across is minus 2. Now it's 7, by the way, because it's in between 6 and 8. Here we're exactly on minus 2, so I can highlight that in red. We've got 7 and we've got minus 2. Okay, so the solution we can write here to the simultaneous equations is x is equal to 7 and y is equal to minus 2. You could leave it as a coordinate if you want to, but it's nice to explicitly say that x is this and y is this. So that there is our final answer to part B. Okay, let's have a look at another example. This is now an example where we've got a quadratic involved. So again, we're doing the same thing. We want to graph the 2 equations here. We've got a straight line and we've got a quadratic. And then B, again, we want to write down the solution to the simultaneous equations using our graph. So don't go and solve them like previous videos. Use your graph, okay? If you're unsure of how to draw this graph, have a look at a previous video because there's quite a few methods that you can use to draw it. So pause and have a go if you want to, and then we'll work through the answer. Okay, if you've paused, hopefully you've got an answer. Let's see whether you were correct. Under this box, I should have, yes I do, I should have my two, well, my linear and my quadratic, my 2 lines. So we can see this is my curve, this is the quadratic, and it looks something like this. Again, my graph's not perfect because I don't have graphing paper, but here is my straight line. Hopefully yours might look a little bit better than mine. We can see that we do have 2 points of intersection, and to find the solution, or just to write the solution down, we just need to write the coordinates of the point of intersection. So in yellow we've got a point of intersection there, and we've got a point of intersection there, okay? So all I need to do, and I'll do this in grey, is from this point, I need to work up to the x and work across to the y. It's not perfect, but I do have the correct answers here. And then this point, I need to work across again to the y and work down to the x, okay? You're going perpendicular to the axes, but my graph isn't perfect. I'm only going off the exact answers here. Okay, so make sure your graph is drawn perfectly in graph paper, then you'll be able to get the exact answer. But the answer, or the solutions, and this time it is solutions, the solutions are, and that's, oops, S goes there, and these are the solutions to this, and I'll highlight it. This curve here has that equation, and we'll do it in green. That straight line has that graph. Okay, so those two there, and I'll just take that away just for the minute actually, so we can see the two intersections there are, well, we'll go with the top one up here. We've got an x value of -1, and we've got a y value of 5. And then we've got this other coordinate here. We've got an x value of 2, and we've got a y value of -1, okay? And I've put them as coordinates there. You could also, like in the previous example, say that. And there's another solution, or I should really say or, actually. I should say or there. X is equal to 2 and y is equal to -1. It is actually quite important that you get this wording correctly, because what it's saying is x is this and y is this, or you can have x as this and y as this, not together. If I wrote and like I did, what I'm basically saying is x has to be -1 and 2, and that's not true. It can't be two things at once. It's either -1 or it is -2, okay, with our appropriate y values. So, hopefully you managed to do that one well. That is the two examples for solving linear graphically and solving quadratic graphically. Now, I'm just going to focus now on quadratics on graphs, okay? So we've had a look at how just then to solve them on a graph simultaneously and what the solution actually represents. But what we can do is we can actually work out how many solutions a quadratic simultaneous equation is going to have. Okay, now remember, with a quadratic simultaneous equation, what you have is you have a linear straight line and you have a quadratic curve. Okay? And what I've got here is it says, after substituting, we'll look at an example in a minute, we can use something's going to go on this straight line, to determine the number of points of intersection. Okay, so let's have a look at an example very quickly from the previous video. This was example 2 in the previous video, solving quadratic simultaneous equations, and we had to solve these two here. We had this straight line and we had this quadratic. So what we did is we rearranged for y, we added 4x to both sides and divided by 5 to give us 1 plus 4x over 5. And then we said, right, that's what y is in terms of x, so let's substitute that into our quadratic. When we did that, we got this here. We simplified along all of these lines, and then, because we substituted y in terms of x, we ended up here at part 3 with a quadratic in terms of x. We had 9x squared plus 117x minus 1026, and that was equal to 0, okay? For every single question, when you get up to that point, when you've substituted or rearranged and substituted, you end up with a quadratic. Now, the two solutions in the previous video for x, excuse me, were those two. X is 6 and x is minus 19. Those were the two solutions. So to this quadratic, we have two distinct solutions. And I'll write that here. Two distinct solutions. And I'll write solutions as that. Distinct, remember, means different. We've got one solution here that's different to another solution. Now, if we think back to a video on the discriminant, we know that we can work out the discriminant, and that will tell us how many solutions that quadratic is going to have. So, let's think about the discriminant here. Remember, it's the bit under the square root of the quadratic formula. B squared minus 4ac is the discriminant. There's three sort of types of discriminant. There's one that is greater than 0, less than 0, or equal to 0. Now in this case, like I just said, we have two distinct solutions, and so the discriminant is going to be greater than 0. Now, what does that mean? Let's go back to this page here, and I'm now going to write that in. The discriminant will go here. So we can use the discriminant to help us determine the number of points of intersection. So here I've just got the same quadratic but in different cases. A is greater than 0 or A is less than 0, and again here greater and less than, and again here greater and less than, because remember, I'll just write that over here actually, less than. If you remember the positive signs of A, so if you've got a positive A and A is in front of the x squared, we have ax squared plus bx plus c. If A is positive, we get this U-shaped, and if A is negative, we get this sort of N-shaped. Okay, so two examples here. I've got this quadratic and a straight line, and then I've got a negative quadratic and a straight line. Both of those, you can see if I highlight in yellow, have 2 points of intersection. Okay, so under this box here, that's what we've got. We've got 2 real solutions. They're going to be distinct, and I could add that in here. Distinct would be quite a good word. 2 distinct real solutions. They are different. One coordinate is here and one coordinate is there. So one solution is this and another solution is this. The same case for the negative quadratic as well. So there we have 2 distinct real solutions. What does that mean in terms of the determinant? For this question, if we had this quadratic and this straight line, we would have substituted just like we did down here, and we would have got a quadratic. So what does that mean for the discriminant here? Well, that tells me, and I'll write that in, I'll go with blue, it tells me that b squared minus 4ac will be greater than 0. Okay, so you could do a little check whenever you have questions, work out the discriminant and see, do we have 2 solutions, and if it is greater than 0, then we do. Okay, let's have a look at this example over here. We've got this positive quadratic and we've got a negative quadratic, and we can see we've got a straight line here. Now, if you remember from GCSE, what this is, this straight line, and I'll tell you here, is a tangent to the curve. So it just meets the curve at 1 point. Okay, so we just have 1 point of intersection, which is the yellow points there. This is the example for the positive, and this is the example for the negative quadratic. So if that's the case, we just have 1 real solution. We've got 1 point of intersection, so we have 1 real solution. And then in terms of the discriminants, that means b squared minus 4ac will be equal to 0. Okay, and if you're unsure on this, do have a look at the discriminant video. Okay, this last case here then, again we've got a positive and a negative quadratic, but you can see here our straight line in both cases does not even touch the quadratic. This quadratic is going to kind of carry on down here like this, something like that, and this straight line is going to carry on like that and all the way up there. Okay, and we can see that's exactly the same case as well for these 2 straight lines, or this straight line and the curve, sorry. That straight line will carry on all the way up there and all the way down here, and that will carry on all the way up there. So we can see they are never going to intersect. If there's no point of intersection, then there must be no solutions to the simultaneous equations, because remember, the point of intersection is the solution to the simultaneous equations. So here we've not got 2 intersections, we've not got 1, we've got no intersections, and so there are no real solutions. And what that means is b squared minus 4ac is less than 0. And b squared minus 4ac is the discriminant, and we take the a, b and the c from the quadratic that we get after we have substituted. Okay, so in this case, a would be equal to 9, b would be equal to 117, and then c would be equal to minus 1026. Okay, so if you want to take a screenshot of that or pause there, you can do. That will help us to understand how many points of intersections we have and then how many solutions we have. Okay, so let's have a look at an example, and it's the final example for this video. We are told that the line with equation y is equal to 2x meets the curve with equation this, kx squared plus 2y plus k minus 2 equal to 0, at exactly 1 point. So that straight line and that curve intersect at 1 point. So in other words, like this example up here, this is our straight line. This straight line is it's intersecting at one point, so it's a tangent to the curve. Okay, this straight line is a tangent, a tangent to this curve, okay, because it intersects exactly at one point. We are told, or we are given, that k is a positive constant. Part A asks us to find the value of k, and then part B asks us for this value of k, find the coordinates of the point of intersection. So, what we have got is, well, the three things that are highlighted. We've got our straight line and we've got our curve. What that is going to tell us is, because they intersect exactly at one point, b squared minus 4ac will be equal to 0. And I'm just getting that from here, okay? One real solution, one intersection point, so our discriminant is 0. And that's 0 once we have subbed our values in. So I'll write here when substituted, or when subbed. Okay, so what I'm going to do before I even start thinking about the discriminant is I'm going to come up with my quadratic, okay? So pause and have a go if you want to. If you don't, we'll work through it right now. Okay, let's have a see what the answer is. So we need to substitute. What I'm going to do is I'm going to substitute y, which is equal to 2x plus 1, into this quadratic here. Okay, so I'm going to have kx squared plus 2 times 2x plus 1 plus k minus 2, and that's going to be equal to 0. Y is equal to 2x plus 1, so wherever I see a y in this curve, I'm going to change it to a 2x plus 1, which I did there. Then I'm going to expand, so that's equal to kx squared plus 4x plus 2 plus, and I'm still going to keep the brackets there, k minus 2. Okay? And I'm going to change that to an arrow because I don't want two equals on the same line. Okay, right, what am I going to do now? Well, now I'm going to group everything together, and we can see I've got a little sort of cancellation here. If we look at this 2 and that minus 2, I can group them together and then they will cancel away. So they will be equal to 0, and I'll end up with that as my final quadratic. So what I've done is I've substituted y is equal to 2x plus 1 into this curve. And then I said, once I've substituted that, my discriminant, because there is an intersection at exactly one point, we are going to have the discriminant equal to 0. I've substituted, I can't do anything else with that, so then I can say a must be equal to k, b must be equal to 4, and c must be equal to k. Don't worry that a and c are, in terms of k, they are both equal to k. Don't worry about that, because what we need to do is find the value of k, and that's going to help us when we substitute into our discriminant, which is equal to 0. Okay, so let's substitute in b squared. That's going to be 4 squared minus 4 times k. That's equal to 0. So that tells me 16 minus 4k squared is equal to 0. I can then add 4k to both sides. 16 is 4k squared. I can divide both sides by 4, and then I'm also going to flip the two terms round. So let me just put some arrows along my working here. That will give me k squared is equal to 4, and then let's square root both sides. Remember, when we square root an equation and we square root both sides, we're going to get plus or minus. Because when we square root, we're saying what number multiplies by itself to give me the number that I am square rooting. So the square root of 4 is 2 times 2. But it's also minus 2 times minus 2, because a minus and a minus gives me a plus. So I'm going to square root both sides to give me k, plus or minus the square root of 4, which is plus or minus 2. Now, I've got two values for k. At A level, all our questions are grammatically correct. So if we're asked to find the value, that means there's just one. If we're asked to find the values, that means there might be 2, there might be 3, there might be many, okay? Here, we were asked just to find the value of k. So what we need to do is we need to find one value. Well, at the minute, I've got 2. But if you remember, it says k is a positive constant. A constant just means a term that is a number. It doesn't change in terms of a variable, which here it doesn't. K is either plus or minus 2. But we can say k must be equal to 2 as k is positive. So we can get rid of that minus 2. So that is my answer for k. Okay? Right, then part B says for this value of k, find the coordinates of the point of intersection. So we know we have to kind of go through this method to find the points of intersection, but we've already done that. We've already done it here. So all I can do is just substitute k into this quadratic. So part B, we had k squared plus 4x plus k is equal to 0, I think. Oh, sorry, not k squared, kx squared. That's right. And then we had k be equaling to 2. So if we substitute k in, that says 2x squared plus 4x plus 2 is equal to 0. And then I need to solve that. And I'm going to solve it by factorising, but first I'm going to have it all divided by 2 because I can do that. So that's going to give me a 1. And then we end up with that. And that, when I factorise, gives me this. X plus 1 all squared is equal to 0. Now, that is as expected, because if we had something like, I don't know, if that was how our quadratic factorised, okay, obviously not that quadratic, it would have been a different quadratic, but if we arrived at something like this, that tells me that x is either minus 4 or x is 2. So that tells me there's 2 points of intersection. But we don't want 2 points of intersection, we want exactly 1 point. So we know we're not going to get 2 brackets like that, we're going to have 2 brackets that's the same, because remember, x plus 1 squared basically means x plus 1 multiplied by itself, okay? So solving that, we can square root both sides. Here we kind of do get a plus and minus, but because it's 0 on the right-hand side, that's just 0. So we're going to have x plus 1 is equal to 0 when we square root, and then we can just minus 1 from both sides. So x is minus 1. Okay, that is our x coordinate, but we need to find the y coordinate now. So all I need to do is substitute, and I'm going to substitute it into my straight line. Okay, so y is equal to 2x plus 1, I believe. Yes, it is. And then if we substitute x equaling minus 1 into there, we'll have y is equal to 2 times minus 1 plus 1, which is minus 1. And then we can say, and so, the POI, which stands for point of intersection, is at x minus 1 and y minus 1. And I'm going to leave it as a coordinate here, because it asks us for the coordinate, okay? So that is my final answer. So hopefully now you know what it's like to deal with simultaneous equations on graphs.